For the PMOS, when the input is 0, we assume that PMOS is on, and when in PMOS the input is 1, we assume it is off. 1 means VDD. In NMOS, when input is 0, we assume that NMOS is off. When input is VDD, we assume it is on. What do you mean by off and on? It means that in a circuit, if PMOS is there, if we have 0 on the input of PMOS, 0 on the input of PMOS will turn it on. Means between these points A and B, PMOS will work as short circuit. And if I have on the PMOS, input is VDD between point A and point B, it will behave as open circuit. This behaves as short circuit, this behaves as open circuit. So I can say that when input is 0, the PMOS work as short circuit, and when the input is VDD, it works as open circuit. In NMOS, when input is 0, it works as open circuit, and when input is VDD, it works as short circuit. You can please note it down on your notebooks or any of the document if you have, because it will be required when we'll be making the this gates. Now, I create a structure in such a way that there you have a PMOS with VDD, then again a PMOS with this, and then you have in parallel two NMOS circuits, and this goes to ground. Let me say that this is the input A, this is input B, this is input A, this is input B. Now I have A, B, and there you have the output. When A and B are 0, 0. If you give 0 to PMOS, the PMOS get turned on, means PMOS will work as a short circuit. So in this case, PMOS will work as short circuit. And if you give NMOS a 0, NMOS works as open circuit. Now, you can assume that here you have the open circuit. So you do not have any connectivity with ground. Getting the point? Because when you have any circuit like this, these are on, so these behave as short circuit. So how this circuit will appear like? This is VDD. This PMOS is short circuit. This PMOS is short circuit. Then again the PMOS is short circuit. Then there you have output. Then below that you have two open circuits. What will happen in this case is that there will be this voltage from this point will start traveling, and this will go till output. So on output, you will get the VDD. But will this VDD get discharged? The answer is no, because there is open circuit. So means when you give A0, B0, the output is VDD. Got the point, everyone? Any one of you who didn't got this point, I can come back to it again. Please let me know. कोई ऐसा जिसको ये समझ नहीं आया? Anyone who didn't got the point what I'm trying to say? Any doubts? Okay. Ashnu wants to explain this again. Okay, I'll explain this because Ashu probably might you haven't studied digital electronics yet, but I'll explain that again. Initially, I said that whenever you have zero in input to PMOS, it is on. One input to PMOS off. One means one or VDD, whatever. And when zero input to NMOS off, one input to NMOS on, right? And on means short circuit, off means open circuit, right? So when I make A and B 0, 0, these both PMOS become short circuit. Short circuit means this will behave like a complete wire. And when this will behave like a complete wire, okay, let me change the color. Okay. When this behave like a complete wire, like this, the whole VDD will appear over here. But this VDD can also move to the ground, can go 0. But for going to the ground, it requires either this path or this path. But these both are open circuits because NMOS in 0 is open circuit. So this VDD will stay. Means whenever you give 0, 0 to A and B, the output will be VDD or 1. Right? I hope I made my point clear. Okay. So let me explain one more point on this. If I have the same circuit with any other input, I have the VDD over here, the output here. Now, in case of any other input, this is A, this is B, this is A, this is B. Now, if I have, let me say the other value 0, after 0, 0, I have A is equals to 0, B is equals to 1, A is equals to 0, B is equals to 1. How this circuit will behave? You have VDD over here. This first PMOS is 0, it will behave as short circuit. The second PMOS, you have input 1, it will work as open circuit. So you will have this sort of a circuit. And then you have the output. Below output, you have this NMOS with 0. This will behave as open circuit. And this is 1. So this will work as short circuit. Now you see this VDD do not have any path to reach to output. And if there is anything on this output, this will go through this path towards ground. So finally, the output will have a 0. Wherever the total current flows towards the ground, it clearly means that you have nothing in the output. Got the point, everyone? Okay. So because either this is short or this transistor is short. In both cases, the output will be 0. So output will also be 0, in this case 1 0. Because in case of 1 0, this will be short and this will be open. Right? And in case the case is 1 1, these both will be open circuit and these both will become short circuit. Again, this will have a 0. So this more or less work as NOR gate. Now, if I change, see, in this NOR gate, I have PMOS in series, NMOS in parallel. I repeat, PMOS in series, NMOS in parallel. I'll change the structure and I make PMOS in parallel and NMOS in series. Sorry. There you have output. This is VDD. This is ground. There you have A, B, A, B. 0 0, 0 1, 1 0, 1 1. These are the 4 inputs. Now you see in this case, this output will be going towards the ground only in one case. When this A and B both are 1. Right? So when A and B both are 1, it is sure that the output will be drained towards the ground. Means 0. In all other cases, you have at least 1 0. And 1 0 means this path will always remain open circuit. Either this remains closed open circuit or this remains open circuit. This path will always be open circuit. Because in all other cases, there is 1 0 at least. And because there is 1 0, at least 1 0, so the VDD will come down to either through this path or through this path or maybe through both. So this will behave as NAND gate, opposite to AND, 1 1 1 0. Anyone who has a doubt that how this works? If there is no doubt, we can move directly towards the simulations. I have created this circuit. Let me show this to you. Because it is very important that you understand that what is happening inside the circuit. Otherwise, doing mere simulations without understanding the circuit has no real value. I have already created a NAND gate for you. You please see this NAND gate. I simplify this for you. So can you see this? This is a circuit of NAND gate. We have two PMOS in parallel and two NMOS in series, and this is V out. This PMOS and this NMOS both have the input VA. This has input VB. This also has input VB. Right? I wanted to explain this because I want to tell you that how to give input in such cases where you have multiple inputs in a single go, that you have four cases 0 0 0 1 1 0 1 1, right? In this case, I have an arrangement. There is a question from Abhishek in chat box. Abhishek says that it means if there is any one input which is low, then output is always high. Yes, in NAND gate, this happens. If any of the input is low, the output remains high. अभिषेक AND गेट में क्या होता है कि अगर आपके पास कोई भी इनपुट लो हो तो आउटपुट जीरो आती है. NAND गेट उससे उल्टा होता है, अगर कोई भी इनपुट जीरो होगी तो आउटपुट 1 आएगी. Still, we can see in this case, if we give 0 from here, we let us suppose that, let me enumerate it before simulating. If I suppose that VA is equals to 0, if VA is 0, it means this PMOS is on and this is off. Now you see, because this is on, this VDD will take this path to go towards the output, right? But this VDD will come here, but this VDD do not have any path to move towards the ground. Why? Because this path, this is open circuit, because this has 0 as input. So the output will be VDD, means high. If you are not getting this point, if you are not able to understand this, please ask me, because if you miss this, then it will be very difficult to understand the further circuits. This is a simplest circuit we have. There can be some problem in understanding this, but once you achieve it, it is very easy to go with the other circuits. Let us say that what is how to do ADL here. Now please see how to use ADL in case of your digital cases. I have transient for, let me say, 80 nanoseconds. I take an input with the name of X with value of 0.8, right? Now in the output, I want to see VA, VB, and output, right? Now, the question is what is VA, what is VB, and what is output? Let us go to stimuli. This ground means 0 volts. VDD means X volts, means 0.8. Now the question is VB and VA. Remember, in case of VDD and ground, please listen very carefully. In case of VDD and ground, we have taken this as a function DC and given the value of DC voltage, 0 in case of ground and X in case of VDD. But in case of VB and VA, which are changeable inputs, in case of VB and VA, which are changeable inputs, we will take it as a type bit. Bit. And how to use bit? Bit means that you want to use it as multiples. Now, what is the meaning of multiples here? The meaning of multiples is very simple, that you want to use it in such a way that there are 4 cases for A and B. It is 0, 0, 1, 1, and now this is 0, 0, 1, 1. Now you see the cases. This becomes 0, 0, 0, 1, 1, 0, and 1, 1. So you want 4 cases of A, this is 0, 0, 1, 1, and 4 cases of B, 0, 1, 0, 1, to make it all cases for output 0, 0, 0, 1, 1, 0, 1, 1. Right? So what we will do is, we will say that one will have the value X, means 0.8. 0 means 0 volts. Rise time is 1 femtoseconds. Fall time is 1 femtoseconds. And the period, see, for how much time a 0 will remain 0? 20 nanoseconds. Apply. Similarly, VA. So, sorry, what is the pattern of bits? 0, 0, 1, 1. Apply. Now, what is VA? 0 is X. 1 is, 1 is X. 0 is 0 volt. Rise time 1 femto. Fall time 1 femtoseconds. Period is again 20 nanoseconds. And the pattern is, there you taken 1, 1, 0, 0, 0, 1, 1. Yes. So here what we will take? Zero, 1, 0, 1. Anyone who did not got this point, what I have just explained, if you want to ask about this, now I show you that how this VA and VB looks like. See, this is your VA, this is your VB. Got it? Your VB is not, VA is not clear. Let me check. There is some A. Okay, VA we haven't enabled. So VA is 0 for 20 nanosecond, 1 for 20 nanosecond, 0 for 20 nanosecond, 1 for 20 nanosecond, means 0, 1, 0, 1. And what is this? 0 for 20 nanosecond, again 0 for 20 nanosecond, 1 for 20 nanosecond, 1 for 20 nanosecond. So what does it mean? What it has become? This is uh, this is 0, 1, 0, 1. This is 0, 0, 1, 1. Right? So it has become 0. See, this is a case of 0, 0. This is 1, 0. This is 0, 1. This is 1, 1. Got it? Anyone is having any doubt on this? Or you want to explain me this procedure again? I'm ready to explain. Don't worry. I want you to understand this. Abhishek, अच्छा ये तो हो गया doubt. Anyone who want to ask anything on this? Okay, so let us check the output now. You see the output. The output says that inputs are Z. Which one is VA? Which one is VB? I want to see. Achha, this is VA. This is 0, 0, 1, 0, 0, 1, 1, 1. If there are two zeros, the output is 1. If there is 1, 0, the output is 1. If there is 0, 1, the output is 1. When the case of 1, 1, the output becomes 0. Please let me know if you have any doubts of, or if you are not able to understand this, how this works, right? So that shows you that how you can make a digital logic gate work. Correct? Everyone okay till here? So I can take it to the next level, because I want you to learn how do we make projects. Okay, so we are left with very short time in this meeting, almost 1 minute. So what we will do, we will close this meeting here, and please all of you join on the same link immediately so that we can proceed from here.